In this lesson, we're going to start talking about inequalities. There's several things that we already know about inequalities, and then there are going to be some new things that we're going to learn. Eventually, we're going to be solving inequalities similar to how we solve equations. But first, let's review and learn a few skills about inequalities. First, let's start with our inequality symbols. Your less than symbol, remember, opens to the right. Your less than or equals to is the same, opening to the right, but we have an equals to line underneath it. Your greater than symbol opens to the left, and then your greater than or equal to symbol opens to the left with the equals to underneath it. The next thing we need to be able to do is graph inequalities. When graphing inequalities, you need to have a few things. You need to have a number line, a circle, and an arrow. All of these things are going to model an inequality statement. When graphing inequalities, the arrow should point towards the possible solutions. For example, the inequality x is greater than or equal to -2 means that x can be any number that is greater than or equal to -2. So to graph this, we need a number line that includes -2 and its surrounding numbers. And then to model all the solutions, we use an arrow and a circle. First, we use a circle at -2. And that particular circle is called a closed circle because this inequality statement includes -2. X is greater than -2, so it's any number greater than. So it's going to be any number to the right of -2, which is why our arrow is pointed to the right. So let's talk a little bit more in depth about the circle and the arrow. In this example, we used a closed circle at -2 because we had the equals to in our inequality symbol. So we use a closed circle for the less than or equals to or greater than equals to symbol. This is going to mean that the number in the inequality statement is included in our solution. Now, if the number in our statement was not included, that means we use the less than or greater than symbol. It does not have the equals to. In this case, we would use an open circle. Let's look at some examples of graphing to see what this might look like. Number 1, b is greater than 3. So first, we need a number line that includes 3. So we're going to place 3 in the middle of our number line and then fill in some of these surrounding numbers. To the right, we would have 4, 5, and 6. Then to the left, getting smaller, we would have 2, 1, and 0. Now that we have a number line that includes the number in our statement, we can draw a circle and an arrow that represents all of these solutions that b could be. b is greater than 3. So at 3, we would have an open circle. We have an open circle because b is not equal to 3. It's any number greater than 3. If we think about our numbers that are greater than 3, an example would be the number 6. The number 6 is to the right of 3. So our arrow would be drawn going to the right. So this models all of the solutions that b could be. Any number greater than 3, but not equal to 3. Number 2, m is less than or equal to -6. First, we need a number line that includes the number in our solution. So we're going to put -6 in the middle of our number line and then fill in the surrounding numbers. Be careful when your number is negative. A lot of times we get mixed up on what numbers are to the left and to the right when we're on the negative side of 0. The numbers to the right getting bigger would be -5, -4, and -3. To the left getting smaller would be -7, -8, and -9. Now that I have an appropriate number line, I can model all of my solutions. My symbol is less than or equal to, which means we're going to include a closed circle at -6. This means that -6 can be included in our solution set. M is any number less than or equal to -6. All of my numbers less than -6 are to the left, so our arrow is going to go to the left of -6. Modeling all of these possible numbers can be solutions to this inequality. Go ahead and highlight number 3, and let's look at number 4. If you notice on number 4, the variable is on the right instead of the left. I suggest that you rewrite inequalities that are this way. I suggest that when graphing, you always keep your variable on the left and your number on the right. If I were to rewrite this inequality, it would be R is greater than or equal to -15. I simply move the R from the right to the left, and the -15 I move from the left to the right. What you do need to be careful with is that if you're switching, you need to also switch your inequality symbol. Notice, originally, the inequality symbol is opening towards the R. When I rewrite it, it still needs to stay opening towards the R. So because I moved the R, that inequality symbol needs to flip. Now that I've rewritten it, I can graph it. I need -15 in the middle of my number line, and then I'm going to fill in the remaining values. So to the right, I have -14, -13, and -12. And to the left, I have -16, -17, and -18. Because my symbol is greater than or equal to, I'm going to have a closed circle at -15. And R is greater than, which means it's going to be all of my numbers to the right. So my arrow is going to point to the right. This helps model all of my possible solutions to this statement. Go ahead and highlight number 5 and number 6. Another skill we need to be able to do with inequalities is translate them, just like we did with equations. Translating inequalities is very similar than translating equations. The only difference is you're going to be using an inequality symbol instead of the equal sign. Just like with equations, when you see the phrase a number, we replace that with x or a variable. And just like with equations, we need to read and interpret less than or at least, no more than, and at most. So these are some common phrases that when you interpret and you translate them, they're inequality symbols instead of equal signs. So when we translate number 7, a number is less than 14. X is less than 14. Once we've translated it, then we can graph it just like we did 1 through 6. 14 being in the middle of our number line, filling in the rest with 15, 16, 17, 13, 12, and 11. We would have an open circle at 14, since it's the less than symbol. And all of our numbers less than 14 are to the left. So our arrow would point to the left. And this models all the possible solutions. And it's very important that you put the arrow on the end because that number line continues. So even though the numbers aren't shown on the number line, I know that 5 is less than 14. Even though it's not on the number line, the arrow helps us to determine the rest of those numbers, even the ones not seen. Number 8, a number is at least 6. So again, a number is translated as a variable, so x is at least. At least means it can be that number or greater. So that's greater than or equal to 6. So then we need 6 in the middle of our number line, and then we fill in the rest, 7, 8, 9, 5, 4, 3. Greater than or equal to means we'll have a closed circle at 6 because it can include 6. And then greater than, all of my numbers greater than 6 are to the right. So our arrow will point to the right of 6. So this means that 6 makes the statement true, and any number greater than 6, such as 7, 8, or 9. This also means the numbers greater than 6 that aren't pictured on the number line, such as 15, 20, or 22, are also included because I added the arrow to the end of my line. Go ahead and highlight number 9 and 10. And then the next thing we need to look at is determining if a number is a solution to an inequality. If a specific number makes an inequality statement true. Number 11, x is greater than negative 9. And we want to know if negative 16 is a solution to this inequality. To determine if it's a solution, you're going to replace the number with, you're going to replace x with the number. So we're going to rewrite this statement as negative 16 is greater than negative 9. Now, when we're dealing with negative numbers in our statement, we want to be extra cautious that we're thinking correctly. Negative 16 is not greater than negative 9. Because remember, the further we get into negative numbers, the smaller they get. So no, negative 16 is not a solution to this inequality. We can do the same thing with 12. Replace m with 12 because I want to know if 12 is a solution to this inequality. So 12 is greater than or equal to 12. Because I have the equals to, I can say that yes, this statement is true. If I didn't have the equals to in my inequality, it wouldn't be true. But because I have the equals to, I can also include the number 12. Let's take a look at one more. Y is less than negative 2.5. And we want to know if negative 2 is a solution to this inequality. So we're going to replace y with negative 2. So negative 2 is less than negative 2.5. Again, being cautious because we're thinking about negatives. And the bigger the number, when we're on the negative side, the smaller the number actually is. So is negative 2 less than negative 2.5? No. Because those numbers are negative, negative 2.5 is less than negative 2. So again, when you're dealing with negatives, be extra cautious as you're thinking. as well as when you're dealing with fractions and decimals. Go ahead and highlight 14, 15, and 16. And remember, when comparing fractions, your denominators need to be the same. They need to be equal. Or sometimes when you're comparing those fractions, it might be easier to draw a picture.